in our Open HPI course about cyber threats by malware, we now want to have a closer look to technical failures that are misused to install malware on the targeted system, on the system of the victims. So technical failures as one of the main reasons for malware attacks, because malware needs an access point into any computer system that could be human factors, we will discuss in the next lecture video, or technical failures. What is a technical failure? A technical failure is a deviation of the state of a computer system from its expected state. So, for example, it could be a software design error. It could be a software implementation error. It could be a hardware error. It could be an administrative error, for example, a lack of knowledge, awareness, bad configuration, or others. So software design errors, to go in more detail, is that we can observe that many software products are designed and developed without considering security aspects in depth. Often software developers are no security experts. The software developer trusts that the security expert with other systems do something to prevent attacks against their software, but in reality it does not work. That's the reason that when we teach software development, that we every time teach the principle security by design or privacy by design, because about security aspects one has to consider in the moment one is designing software. So entire Internet Protocol suite has been designed almost without security mechanisms. I already mentioned this when I told you that the Internet started as a research project, and then the prototype was immediately used and got this popularity and big application around the world. So also this protocol suite, the IP protocol, TCP protocol, UDP protocol, they come almost without any security mechanisms. Same as with application protocols like FTP or NFS transfer. Both transfer passwords in plain text, so that everyone can, who has access to the internet infrastructure, can also have access to such kind of sensible data. TCP/IP cannot predict network nodes. It's not clear how the route is chosen through the internet. It can be differ from packet to packet. So network sniffing is possible and very dangerous for the users. So if one looks to the early internet standards, they even explicitly state that security concerns are not covered. Even if in the design of a software also protection mechanisms are foreseen, then this design has to be converted into program code. This is called implementation. So also in the course of the implementation, errors can occur that later provide possibilities for the attackers to exploit these errors to attack a system. So although design of a software may be secure, the implementation can open holes for attacks. So for example, unchecked inputs, that there is no check how long the input is, and this we know, for example, by buffer overflow attacks, the attacker gives much more input in, and then it is not deleted. It is simply checked in the system. Missing fallback criteria. So the attacker can try out things. They can try to do something. So even if the system owner sees that someone tries to misuse the system, there is no security protection against this. Then missing distinction between user groups is a very often misused reason and opens doors for attackers. So some users have deeper rights, for example, administrators, compared to standard users. Standard users should not be able to easily install a system or to switch off another system. This is the task of administrators. So in many implementation, also simple users have rights to so-called super user rights to do something serious with the system. But often the standard users have not the knowledge for such kind of activity. So a professional programmer should divide between what can standard users do, what can administrators do. Eventually there are even more roles to provide. Then insecure cryptographic methods, they provide tools for attacks. Hard-coded keys or passwords, hard to understand code without any commentation, code that is not available for checking. Test backdoors, all which are not closed after the tests, or the typical default access possibilities to a program when the program is installed. They need to be closed after the installation, but often they are not. This all provides holes for attacks that the attacker can misuse. If we look to the hardware, then also hardware errors and failures help the attacker to install their malware on the systems of the users. So, for example, substantial security risks come from unreliable, unprotected or faulty hardware, design errors in the different components, open ports in the facility, for example USB or RJ45 as examples for such kind of attacks, insecure reboot sequences, for example in case of power outage. This is one of the motivations for denial of service attacks, to let the system crash and then system automatically restarts, and often if it's not correctly configured, then it restarts in default settings which are known to the attackers and can be misused. Physical accessible devices, for example Wi-Fi router, switches, terminals, computers, can be manipulated. The attacker can install their malware on that systems. Also administrative errors are provide possibilities for attackers, like lack of awareness. So administration errors, is a common source for attacks. So for example, default credentials, such as username, root, password, root. These are when a system is spied. Then there are default settings that the user, after installation of the system, can start to configure the system. And of course, the default credentials, the default access ways, they need to be closed, otherwise all people that know the default credentials can access and can misuse the system. Wrong domain settings or errors in the settings of a firewall, of an intrusion detection system, of an IPS, of a spam filter, of a sandboxing environment. This all are protection measures and protection tools. And if they are configured in a wrong way, then they can be overcome by the attackers. Generally, there is a lot of software on a computer that's not used by the user. So unused standard software and components provide possibilities to attack a system, to misuse vulnerabilities for installing malware on a system. Errors in networking, reverse proxy routing provides a possibility. and very important, missing patches and updates of old hardware and of old software are a huge problem for users and are provide a very good situation for attackers, because they can misuse known vulnerabilities, by means of known exploits, to the end of installing malware. Working with administrator root accounts, these are important failure sources that support security attackers, cyber criminals, to install their malware. If we look to the security practices in software development, we have to say, as errors and failures are wide-ranging, the security precautions need to be taken serious. So here is a list which proposes the best security practices for secure software development, and often this is not known to the developer. So advice is give the least privilege for an application that is needed to run this. This is to prevent to give the highest privilege, the administrator privilege, which of course allows to do all things on a computer. Avoid security by obstruction. So use methods, show methods, discuss methods, security methods with others to find by these colleagues, by the good peoples, to find rules, to find problems that later on can be misused. By the way, that is a very important argument for open source. Open source that could be checked and evaluated by everyone. Keep security measures simple, because the more complex systems are, same is true for security systems, the more mistakes they can contain, and the more difficult it is to detect these mistakes, which can become vulnerabilities that can be misused by the attacker. Another advice for best security practices is to minimize attack surfaces. That means delete all unneeded programs. Also on your smartphone, on your computer, programs that you are not using, that you are not need, you should uninstall, because even these programs provide attack possibilities by their vulnerabilities that can be misused by the attackers. So there is a wide range of technical failures which help cybersecurity to perform their cyber threats by malware.